Welcome to the ET302 how-to video for diodes in Diode Lab. Here I am, and I opened up our PS1A multi-sim file. And this is the first one in 1A diode circuit, so let's go ahead and power it up and open up all our meters. So our voltage across our diode is 0.549 volts, which is reasonable for that. And what we're going to do is, since we're using up that much voltage, we have to subtract a diode's worth from our 5-volt power supply, and that leaves us the 4.451. And that leftover voltage is going to be across our resistor, and that's going to give us our 4.51 milliamps, which is the 1K value. And then what we're going to do is we're going to fill that in the chart, and since this is one diode, one resistor, we're going to get that voltage subtract for this one diode, which should be the same or close to it. So let's go ahead and do the next one, and then we're going to change this to 10 volts. Okay, and let's start it again. We have pretty much the same diode voltage. It does change because of that curve that they have, and when we subtract that from our battery across our resistor, and we get the 9.4 milliamps. And that's the way that this circuit will operate. Okay, back to multi-sim in the lab. Let's do part 1C. And if we look at the circuit closely, this diode is reverse biased. Okay, being he's reverse biased, there's going to be no current flow, and it's open, and we are going to get the full battery voltage across our resistance, and we're not going to have any current because we don't have direct flow. So, but it will give us the full value because our meter is essentially passing the voltage around it. So let's go ahead and start it and see what we get. And we get the full voltage, and this guy should be pretty close to 0. That's microvolts, and our current should be nanoamps, which is essentially 0. So okay, let's work on part 1D, parallel diode circuit. So we have two parallel circuits, and let's go ahead. Is that the correct 1K? 1K. Nope. So let's change this to the very first one. So we're going to change this to 1. Okay, let's change this guy to 1. Okay, let's start the circuit. Okay, so what are we going to get here? Well, it's parallel to our battery, so it's going to be 12 volts. Okay, and this guy, parallel to our battery, 12 volts. So what happens here, and we're going to measure the voltage, so it's going to be one diode's worth, 0.6, and this guy is going to be what, 12 volts minus the 0.6. Let's see, and it is 11.4 essentially. Okay, parallel circuits, voltage is the same. Okay, we have opened up part 2A, which is PS2A, and we have a transformer circuit. The very first one that we have 100 volts in, which this is 141 volts peak, would be equivalent to RMS of 100, and I'll show you that in a minute. Let's go ahead. This primary to secondary, we're going to use a turns ratio of 1. So that means that the number of turns on one side is equal to the turns on the other side. So let's start it up, and let's turn on our meter. and turn on this. So our DMM measures an RMS, so we have 100 volts RMS, and being it's a 1-to-1, we measure 100 volts out, and our current's going to be the same because it's a 1-to-1. So let's take a look at our and let's see here. So 200, and being this 1-to-1, let's go ahead and turn one of these off, and you see the red underneath and the blue on top, and they're both the same. All right, and they're in phase. Okay, I've opened up part 2B, transformer current characteristics, and I've zoomed in. First thing let's do, we've got some issues with, let's make this a 1-to-1, and this is 10 ohms, good. This one is inline, so he's got to be current. So we want to make sure we set him to AC current. Good. This guy is voltage, but he's AC voltage. This is a transformer, so it's AC to AC. Transformer only works under AC conditions. So, and this be current AC. And we could take a quick look at our, there we go. So let's go ahead and take a quick look at our oscilloscope, and they should be, since it's a 1-to-1, they should be on top of each other, which they are. Okay, so let's shut him off, and let's take a look at what we have here. So we have 1-to-1 ratio, so we're looking at current now. Okay, so this is 1-to-1. Our voltage is the same voltage, and we have the same ratio for current. It's an inverse relationship, but it's still 1. So we have 10 amps because we have 10 ohms and 100 volts, 10 amps, and it transfers back to 10 amps. Okay, let's go to our second measurement on that same chart, part 2. So we still have 100 volts in, and we're going to change our tune ratio to 2. But in this case, yeah, we'll just leave it at 2. Multisim is actually backwards or inverse from what we normally consider a transformer, but let's go ahead and do this. Okay, so we got a factor of 2. Okay, so our voltage is going to reduce by a factor of 2, 100 to 50. So what happens is 50, 10 ohms going to be 5 amps. Okay, because of our turns ratio, so our voltage goes down, our current goes up. They're inverse relationship. So if we have 5 amps out, we have 2.5 amps going in. And you'll see that relationship throughout this part of the lab. And as far as a real transformer, just skip that. We don't have a real transformer for you.